The equilibrium state is one in which there is no net change in the quantities of reactants and products. But do not confuse this with a state of no change. At equilibrium, the forward and reverse reactions continue but at identical rates, essentially cancelling each other out. These factors include a change in temperature, pressure, reactant concentration, and product concentration. When any of these factors are changed, the equilibrium point of the reaction will move and the concentration of products and reactants in the system at the new equilibrium point will be different.
Part A. Material and apparatus. Bottle A, carbonated drink. Bottle B, carbonated drink. Hot water. Ice cube. Procedures. First, shake both carbonated drink bottles. Second, observe the bubbles formed in both of bottles A and B. Then, place bottle A in hot water and bottle B in ice bath. Leave both carbonated drink bottle for 5 minutes. After 5 minutes, take the bottles out of the basin and use cloth to wipe both bottles. Observe the bubble formation in both bottles. Compare the before and after bubble formation in both bottles. Part B. Material and apparatus. Bottle A, carbonated drink. Bottle B, carbonated drink. Teaspoon. Vinegar. Cotton cloth. Procedures. First, gently shake each of the carbonated drink bottles. Observe the bubble formation in the bottle in both A and B. For the result, open the bottle cap of bottle A. Then, add 2.5 ml of vinegar into it and close the bottle immediately. Observe the bubble formation. And lastly, record the observation. Discussion.
Change in concentration. The concentration of the reactants or products added is relieved by the reaction which consumes the substance which is added. The concentration of reactants or products removed is relieved by the reaction which is in the direction that replenishes the substance which is removed. When the concentration of the reactant or product is changed, there is a change in the composition of the mixture in chemical equilibrium. For the second step, we first gently shake each of the carbonate drink bottles. After shaking both of the carbonate drinks, we can see the bubble formation in bottle A and B. Carbonate beverage contain carbon dioxide that has dissolved under pressure. Therefore, when we shake the bottle, we encourage the formation of these bubbles which get trapped in the foam. After shaking both of the carbonate drinks, we open the bottle cap of A to add 2.5 ml of vinegar into and immediately close the bottle. There, we can see more bubble formation happens when changing the concentration of one carbonate drink's concentration. This is because the addition of vinegar is reduced by shifting the equilibrium from left to right so that the added vinegar is consumed. The bubbles formation occurs to a larger extent than the reverse reaction until the new equilibrium is established. Change in temperature. The effect of temperature on chemical equilibrium depends upon the sign of H bar of the reaction and follows Le Chatelier's principle. As temperature increases, the equilibrium constant of an exothermic reaction decreases. In an endothermic reaction, the equilibrium constant increases with an increase in temperature. Along with the equilibrium constant, the rate of reaction is also affected by the change in temperature. As per Le Chatelier's principle, the equilibrium shifts towards the reactant side when the temperature increases in case of exothermic reactions. For endothermic reactions, the equilibrium shifts towards the product side with an increase in temperature. Our experiment for set A is an endothermic reaction. Thus, increase in temperature increases the formation of product which is gas bubbles. It can observe that bottle cap in hot water produce more gas bubbles compared to the other bottle. This is because the equilibrium shifts to right to produce more products to absorb the added heat, resulting in more bubble formation.
In conclusion, yes, the hypothesis is accepted and the experiment was successful because if the concentration or temperature of a substance is changed, the equilibrium of the substance will change to minimize the effect of that change. Le Chatelier's principle was observed in this experiment. The principle states that when the conditions of a system in equilibrium are changed, the system reacts to counteract the change and re-establish equilibrium. The equilibrium is disturbed when any of the reactants or product are disturbed. As we all can see that the data we have collected from both experiments from part A and B both confirm that Le Chatelier's principles were indeed correct and applicable. As the principle states, when the different substances were added to the carbonated drinks, the equilibrium had shifted accordingly in order to gain balance again. The shift in equilibrium resulted in a change of bubble formation for each mixture. That's all from us. Thank you.